Hello, teacher. Okay, so today what I'm going to do is do these three things in MATLAB. We're going to graph them out. And I have learned that I should not have a lint space of 100 values because it kills my computer, and that's not good. And I have to re-record everything if it does that. This is the second time I'm recording this, so I hope it doesn't do that again. Okay, so first off, for the surface. To do a surface in MATLAB, what we want to do is essentially it depends on how the problem is given to us, but we can see that x, y, and z in this case are dependent on u and v. So what we're gonna want to do first off is do an array of u, which is equal to 0 to 2 pi, because it looks pretty if I do 2 pi, comma, let's do 20. What this does is essentially that it creates an array from this value to this value with this amount of values in that array. So we're going to do that for both of these. And this gives us the ability to make arrays that are the same size, which is good, because if we don't have arrays that are the same size, MATLAB doesn't like that. So we're going to do that. Now we're going to do what it says here. We're going to graph it out. So x equals okay, here we go. X equals cosine of u to the 3. We have to put a dot here because if it's an array, we have to put a dot. It's just the rules. Dot times. There we go. If it's an array, it uses a dot because normal in exponentials and multiplications are just for single values, and we are working with arrays here, so we can't do that. We're going to do the same for y. Well, we can see that for y is a little bit different. Here it's sine, so we're going to do that. And finally, for z, it's going to be sine of v. Here it's v, here it's v. And then with that, what we're going to want to do is just do a surface plot of x, y, and z. And with that, wait, let me put this because it lowers the amount of displaying power that it requires. It does everything internally, so we just wait a bit. Oh, there's already a mistake. Common parentheses. Oh, I forgot the lint space function. There we go. Is everything alright now? Okay. That should run now. Z must be a matrix, not a scalar. Oh. There you go. Perfect. Now let's see what it does. But it is a matrix. What do you mean? Oh, right. I forgot an important step. Okay, we have to do a mesh grid of u and v. Because if it's not, then it's just an array. And right now, if we did this, essentially it's just going to make an array of z, and we don't want that because z also has to be a matrix, because even if the value of u stays the same, it still has to be a matrix so that MATLAB can use it. So u comma v, my mistake. I'm sorry, I forgot. So let's replace everything here with capital U and capital V. There we go. Now it should work. Perfect. Okay. What it generates is a little bit interesting. Very interesting. Look at that. So weird. let's try doing it with 1 and 1. It's very interesting what this specific one generates. I don't know. I'm not too sure what this means. What about -1? Let's see what happens with that. Oh, I see. Let's do pi minus pi 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 pi. It's doing it again. So let's do 0 and 0. Okay, and it's just okay. Oh wait, perhaps we can do 2 pi for a single one. Let's see what happens here. Ah, very interesting. We have correctly made the figure that we were supposed to do, I think. I'm gonna up these because it looks a little bit ugly to 30. Alright, perfect. That looks very good. That looks very interesting. Okay, so that's our surface plot. We're done with this one. Now we're gonna do. Am I still recording? I have to check. Okay, good. We're still recording. We're still alive. Now we're gonna do the line integral with the surface underneath. What I assume you want with this is essentially like a line, and it has like a curtain essentially, like right here. You want this essentially. So that's what I'm gonna do. So first off, what we're gonna need is we're gonna need to plot out r of t, and we have t as a single value from -32. So we're gonna do that. T equals then space -2, comma 2. Let's start with 15. I don't know, random stuff. And we have I, j, and k, so we can just do x equals t. This is I. Actually, I'm just gonna label them I. J equals t. K equals t dot squared, and this is 2t. And then with that, we use the plot 3 command. I, comma j, comma k. And then we just run this, and we can see that it does a surface plot. This is fine and dandy, of course, but we need to have our surface under the surface. We have our line integral, but we need the surface underneath. So what we're going to do now is grab this over here and make it so that we have the values that make this up. So let me see how I did it before, because I already did it. Okay. So essentially, what we're gonna do is take I, S, we're gonna call it, for I of surface, and essentially it's gonna go from a coordinate I to another coordinate I for a specific point in the surface. So we're gonna do I, comma I, like that. Yep, so we do it. We're gonna do the same thing for J. And let's do the same thing for Z for now to see what happens. Okay, I mean. Alright. Let's see what happens. Nothing. Oh, right. I forgot to plot it. So let's plot it. It was. Oh my god. I'm sorry. I don't know what's wrong with it. Stingy. Okay. Surf again. IS, comma, IJ, comma, KS, if I'm not mistaken. Sorry. JS. There we go. Z must be a matrix, not a scalar or a vector. It has happened again. What does this happen? I don't know. But essentially, what we have to actually do here is that we have to make it so that Z goes from not the point on the line, but to Z0. So to do that, we can just multiply it by times 0, I think. Let's see what happens. It's not working. Why is it not working? It worked earlier. Let's try an exponential. It's not working again. Okay. Let me see what's wrong with it. I did it just earlier. Quiver. I have to use quiver? Oh wait, no, that's for the third one. My bad. Spoilers. Plot 3. Hold on. Oh, it's... Oh, I see. Okay, I did it wrong. Alright. I used the wrong ones. Okay. There we go. And there we go. We have our thing. We have our line integral with a surface underneath. Perfect. And we're gonna up this value because it's ugly, and I don't like it being ugly. I want it to be pretty and beautiful and colorful. And because these are actually two, that's not good. So we're gonna just go ahead and do a hold on here, so it does it in the same one. And we have it. Look at that. And that's the second exercise. We have our line integral, and with the surface underneath, which with z equals 0, and that's it. Alright, now for the third one. Am I still recording? I am. Yes, I am. Okay, good. I hope it doesn't die. F of z equals x, comma y, comma z. All of this, r of t equals that. Okay, so essentially, here we have this line integral. Again, this is r of t. We're going to leave this for later. But first off, we need to do the vector field. Now, the vector field is pretty interesting because for the value of x, y, and z in the 3D space, this function will determine where the arrow points. So what we're going to do is do 3 length spaces for x, y, and z. First off, x, like that, y, z. Can we have a value? Okay, we can't have values, but for now we're going to do minus 5 to 5. Wait, no. Minus 10 to 10. Minus 10 to 10. And minus 10 to 10. Why? Because I can, and also because it makes it easier to see if it's inside of what will be essentially a 3D matrix of sorry, a 3D matrix of arrows pointing in different directions. So we have our length space, and now we do our function. So I is going to be equal to x plus y dot squared. J is going to be equal to j equals minus z times x, and k is going to be equal to y plus z, and that's it. That we've got our functions, and now to do the vector field, what we're going to do is use the quiver3 function. And we're going to give it all of these inputs. So x, comma y, comma z, comma I, comma j, comma k. And it's going to do it on its own. Let us observe. Put this here so it doesn't make the thing. Oh, right. I have to put a dot here because it's still on the right. And oh no, oh wait, right. I forgot to do a new figure here because it's not the same as this one. Okay, that's interesting. It's different from when I did it yesterday. It's very different from when I did it yesterday, actually. Why is that? Why is that? What happened here? Did I do it upside down? Figure. Hold on. Nope. Seems to be fine. Oh, right, it has to be a mesh grid. I'm dumb. Sorry. It has to be the same as this one because it's the same thing that I explained earlier. I just forgot. Equals. Let's do x, y, z equals mesh grid. There we go. Okay, let's see if it works this time. Oh, I wrote mesh grid again. It happened in the previous iteration of the video, and I forgot to. Okay. What do you mean must be the same size? What do you mean they aren't the same size? Okay, I got the same mistake yesterday as well. I don't know what's happening. 10, 12. What is happening? Oh my god. What is happening here? Can I add the dots to the pluses? No. No way. What did I do wrong here? Let's see and check. It's fine here. This goes after. Quiver 3. X. It's the same. I don't know what's wrong. I really don't. This is very I don't. What's happening here? Hold on, let me figure this out. I can't cut the video, so I'm gonna have to figure this out because I do not want to record this again. Quiver 3. Let us seek help on this thing. Z and U must be the same size. Aren't they the same size? Hmm. 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 So is U. This is Z, and this is U. Dude, wait. It's not working. Why isn't this working? I see. I used I didn't use the mesh grid values. Okay, there we go. That was the mistake. My bad. Okay, let's run it again. There we go. Now it works. Look at that. So pretty. But I think 10 is actually fine. Because then my computer would die. I do not want to record this another time. And there we have it. We have our field. Yay. Breathtaking. It seems to be going very weirdly. It's doing very weird shapes. Now that we have our vector field, we're going to want to do our line integral. So we're going to do r of t. Wait. Yeah, okay. X. Actually. R. We're going to r f f. We're going to give it an no. Okay, we're going to give it j f and distinguish it from field. That's how we're going to do it. And we're going to just write it I f j f k f. Alright. Now that we have that, we can do this. T equals linspace from 0 to 2. Let's do 30 values as well. X, we're going to do x of L. XL equals T squared YL equals T to the third power. ZL equals sorry. Oh, throat. Minus 2 times T. I'm going to do hold on. Go down here. Do just the same thing as this one, which is going to be plot 3. XL, YL, CL. We're going to run this entire section, and voila! We have our line inside of our field. Breathtaking, isn't it? Genuinely. So breathtaking. We're going to make it a bit thicker. Let's see. How do I line stuff? I think, wait, hold on. Let me see how you did this to make it a bit thicker. 0.2, is that it? Okay, let's try that. 0.5, I don't care. Wait, no, my bad, that's for the veil thing. Ah, there we go. Line width, okay. Comma, line width, 0.2. No, 2, no, 5. I don't care, I'm gonna make it thick. Yes, look at that line. Perfect. Okay, so that's it. We've got our vector field and line integral in vector field. We've got our line integral with a surface underneath it. And we've got our surface. We did it. We solved the puzzles. And I kind of explained how they work along the way. I hope this is enough. I'm gonna go have dinner, and I'm gonna do the last video of the period. Ugh. Okay. Have a nice day, teacher. Thank you very much. Goodbye.